Okay, chapter 3. To begin this off, this chapter talks about equations with two variables. So up until now, you may have had variables on both sides of the equations, but there's either only been x's, only been y's, only been n's, whatever it happens to be. So now you're going to be dealing with multiple variables. So it is a little different, and you will have to get used to it, but it won't be anything you can't handle. So this is more realistic, maybe, as to what is going on. So if you look at this real world link, it talks about Marcus can download 2 songs from the internet each minute. This is shown in the table below. So it talks about time in minutes, which they give the variable x. So 0 songs, of course, 0 minutes. 1 song, 2 minutes. 2 songs, 4 minutes. 3 songs, 6 minutes, and so on and so on. It says compare the change in the number of songs y to the change in time x. What is the rate of change? So this is actually what this first lesson here is talking about, which is a rate of change. So later, whenever we talk more about graphing these lines, we're going to talk about rate of change, which we also refer to as slope. So right now they just want to know what is the rate of change. So for every song it goes up 1. For every minute it goes up 1. For every song it goes up by 2. So it says compare the change in the number of songs y, so that is written first. So y, compare it to x. So if you compare y to x, the number of songs increases by 2, that's your y. The number of time increases by 1, so it's 2 songs per minute. So that is your rate of change, 2 over 1. All right, now if you're going to graph that, it says graph the ordered pairs from this table, label the axis. Let's clear this off here. So let's put it up just a little bit farther so that way we can write on it. Label the axes. So if we talk about, we said that x up there, which is kind of off the screen now, but we said that x was your time in minutes. And remember that the horizontal axis is the x. It says right here, x. So that's your time. And you do that in minutes. Which leaves this to be y, which was the number of songs. It's an S-O-N-G-S. So it does not look like songs. Squinting, it probably does. All right, so label your axes, which we've done. So now we need to plot our points. And it said for 0 songs, 0 minutes. That's an easy one to do. 0 songs, 0 minutes. And then for 1 song, it took 2 minutes. And then for 4 songs, it took 2 minutes. Wait a minute. What we've got here? We've got 2 songs, 1 minute. I put that on the wrong spot. See, and if you were right here with me, you could have said, no, 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 that's the wrong spot. All right, so let's go back here. 0 songs, 0 minutes. 2 songs, 1 minute. So 2 songs, 1 minute. 4 songs, 2 minutes. 6 songs, 3 minutes. And 8 songs, 4 minutes. Those are our data points from up top there. Now, if you look at this, we've also got a line that appears right through them. So those dots are linear, which you can hardly see them now because they're all covered up. But these are your dots. These are your data points. All right? They appear right on the line. That relationship is linear, and that's what we are talking about today. All right, so let's go on to the next page and try a couple more. All right, so linear equations, linear relationships, that is what we are just talking about here. So these are relationships that have straight line graphs, which we just shown you, like the one on the previous page, called linear relationships. Notice that as the number of songs increases by 2, the time in minute increases by 1. So we've just talked about that. The number of songs increased by 2. The number of time, the number of minutes increased by 1. So that is your rate of change, and we just did talk about our rate of change being 2 over 1. I'm fine if you leave it like that. You can put 2. Whenever we start graphing lines, it will be more, I don't know, you'll probably want it left as a fraction. So I'm fine with you leaving that there for now. Okay. So it says the rate of change between any 2 points in a linear relationship is the same or constant, which just means it's going to be 2 over 1, 2 over 1, 2 over 1, 2 over 1. If I were to make any of these fractions, 4 over 2, 6 over 3, 8 over 4, they would all reduce to 2 over 1. That is a constant rate of change. Constant means that it's not going to change. It's the same no matter what 2 data points. It would always reduce to 2 over 1. All right, so next example. It says the balance in an account after several transactions is shown. Is the relationship between the balance and number of transactions linear? So in other words, you have to look, does it have a constant rate of change? Does it have a constant rate of change? Well, if you look at the number of transactions, for every 3, it goes up, right? 3, 6, 9, 12. The balance is doing what? Going down by 30. So since the rate of change, now the rate of change is usually the second one compared to the first one, and it's like that every time. The second one compared to the first one. All right, so we want the relationship, go by what it says, the relationship between the balance and the number of transactions linear. So it talked about balance first, so we're going to put balance on top. Number of transactions second, so that would go on bottom. So the balance, what's happening to the balance? It's going down 30. And what's happening to the transactions? It's going up 3 or just a positive 3. Now if I were to reduce that, negative 30 over 3, negative 10 over 1. So always go by the order that they ask you, and usually it will be in reverse order. And again, that talks more about slope in the coming lessons. So it talks about the rise over run, change in y over change in x, and all that's coming. But for right now, just go by what they say. What they say. So this table right here did represent a linear relationship because it had a constant rate of change. So I want you to go ahead and pause it, and I'll get back to the right page. Wow, that thing's flying. I'll get back to the right page, and you can do, try the 2 under got it. And come on, honey. This is actually a short lesson, although you wouldn't know it because we have to go back and forth between so many pages. And now everything's blue. Almost there. Gosh, dang. Really? It's like if it's at the very end of a page, it doesn't want you to stay there. Let's try it. Maybe do baby steps, baby steps, baby steps, baby steps, baby steps. Okay, we'll leave it right there. So, got it. Try those problems, and then we'll come back. Okay, after all of that, we need to talk about A. Talk about A. What's happening here? Well, for every 5 minutes, this is going up. What's happening here? That's going down 5, down 4, down 4. So since it is not a constant rate of change, this is not linear. This is not linear. And that is not linear because it did not change the same all the way through. So from here to here, it went down 5, and from here to here, it went down 5. That's fine. From here to, up here it went up 5. And so from 10 to 15, it went up 5, but look what happened from 90 to 86. It went down 4. This is the problem right here. Here it changed 5, here it changed 4. That is not constant. Since it is not constant, it is not a linear relationship. Let's try B. All right, so for B, let's see, we've got the first data point right here. So as this goes up 8, this went down 20. Right? It went down 20 from 80 to 60. The next data point, it went up 8. Guess what? It went down 20. So up 8, down 20, up 8, down 20. That is linear. There is a constant rate of change. So this is linear. That is linear. Okay. Moving on to proportional linear relationships. So same kind of thing, only they just add one other twist. Oh, what now? Now you don't want to go so fast? What? Crazy board. All right, proportional linear relationships. Two quantities, A and B, have proportional linear change if they have a constant ratio, so constant rate of change, and a constant. So constant ratio and constant rate of change. So let's look at these. Example 2. Use the table to determine if there's a proportional relationship. So first of all, we got to say, is there a constant rate of change? So constant rate of change between the temperature in degrees Fahrenheit. So it says that one first. So it talks about Fahrenheit first and Celsius second. So Fahrenheit first, it's going up 9 every time. That's where that 9 comes from. And then in Celsius, it's going up 5 every time. So it does have a constant rate of change. So this is, in fact, linear. But we're going to talk about, is it proportionally linear? Proportion means it's going to have the same distance every time. So if we look at this example, 32 over 1, 41 over 50, 41 over 5, 50 over 10, 59 over 15. If I put 41 over 15 and divide, I get 8.2. 50, I think I said that one, 41 over 5, you get 8.2. 50 over 10, you get 5. 59 over 15, you get about 3.9. So these proportional values aren't the same every time. They're not the same every time. So even though this is a linear relationship, it is not proportional. It is not proportional. So there is a difference. There is a difference. It does have to have a constant rate of change. So we talk right here. The points appear to fall in a straight line. If I'm going to graph these points, 0, 32, 5, 41, 10, 50, 15, 59, 20, 68. So they are linear. They do form that straight line right there. So they are linear, but they are not proportional because they do not pass through the origin. Right? It doesn't go right through the origin. And these are not the same every time. Okay. I think we're just going to go ahead and go on to some guided practice here. It says the amount of paint needed to paint a certain amount of chairs is X, as shown on the table. Is the relationship between the two quantities linear? So does it have the same rate of change? So as you go up 5 chairs, you're going up 6 cans of paint. 5 chairs, 6 cans of paint. It is, in fact, linear because it does have a constant rate of change. Now, what is the constant rate of change? So it talks about the amount of chairs X is shown, relationship between the two quantities linear. And like I said, they usually want Y first. So Y over X. So I've got 6 over 5 is its rate of change. 6 over 5. All right, as always, I'm going to wish you luck before you start your assignment, but there is one thing that I would like you to really pay attention to whenever it's talking about the rate of change that you're talking about. Remember I said if they give you X and Y coordinates, this is the X, this is the Y, they are talking about the change in Y over the change in X. That's how it always goes. Change in Y over the change in X. Unless it specifically talks about, I want this compared to this. So pay attention to the order they ask it, or it's this. This is how I'm going to know if you followed all the way through to the end of this lesson or not, if you took notes on this part. So change in Y over the change in X, Y coordinate over the X. So good luck, and I'm sure you'll have questions to see me tomorrow.